Section 1.2 is about solving equations using a graphing utility. Let's go ahead and fix that using a graphing utility. That would be something like Desmos or your graphing calculator. It is up to you. So an equation of one variable is when two expressions are set equal to each other, right? It has to be an equation. It has to have an equal sign in order to be an equation because they're equal equation. I like kind of looking at the English. So here's a few examples. Here's a degree 2 equation. Here's our rational equation, right? And when we're solving an equation is we're finding the solutions or roots of the equation. Roots is another word you might have heard when working with finding the zeros of a function. We're wondering where that function crosses the x-axis. So those are going to be our x-intercepts. Something to keep in mind. So there are a few types of equations. So one is conditional equations. Conditional equations have finite solutions, right? It doesn't have to have just one. Linear equations have one, but degree 2 equation, quadratics have 2, cubics could have up to 3. So it's important to note that they have a finite number of solutions. Identity equations have infinite solutions. What does that look like? So first off, most of the ones we're going to come across in this class are going to be conditional. But for example, something can have an infinite solution. So what if I have 5x minus 15 equals 5 times x minus 3? Why don't we go ahead and simplify that? I'm going to distribute my 5. I have 5x minus 15 equals 5x minus 15. These are both equal. 5x equals 5x, so x equals x. Is this a true statement? Yes, this is true. And it will always be true. It's true regardless whether x is the square root of 2 or 5/8 or negative 10 to the 6th, right? We're going to have a true statement. So because it's true for every real number, we would say it has infinitely many solutions. The other special type of equation we're going to come across would be a contradiction. Contradictions have no solutions. Let's take a look at this example. X equals x plus 1. When could this ever be a true statement? Well, it couldn't. If I solve, I get x equals 1, which is not true. So you're always going to, if an equation is an identity, you'll end up with a true statement. That true statement could be x equals x. It could be 2 equals 2, as long as you get a true statement. If you get a false statement, that means you know you have a contradiction that has no solutions. You can denote it like this. So in order to solve an equation using a graphing utility, right, you can write the equation in the form of the expression equals 0 and graph it and make sure you can see the x-intercepts on your screen. Those x-intercepts are going to be the solutions. You can use the 0 utility on your graphing calculator. You can take a look at Desmos. So why don't we go ahead and solve an equation? Why don't we go ahead and see, okay, what are the zeros of x squared plus x minus 6 equals 0. And I want to know what are the solutions to this. So I'm going to go ahead and plot this in Desmos. So let me click next so we can get to the Desmos link. So I said I was going to have x equals x squared plus x minus 6. So it's telling me my solutions here are 3 and 2. It's my x values that tell us our solutions. Sorry, they're 3 and 2. Now what if I wanted to solve this problem another way? Well, let's check that out. I could solve this equation by factoring. We're going to talk about that later on. But if we wanted to factor this, we'd see that this factors to x plus 3, x minus 2. If I set these equal to 0, right, individually, I have x plus 3 equals 0, so x equals negative 3, and x minus 2 equals 0, so x equals 2. So that's one way set it equal to y and solve for the roots or zeros of the function. The other way to solve an equation using a graphing utility would be to use intersect. Intersect is a function programmed into your graphing calculator, but you could also use Desmos. So what you want to do is you want to have one side of your equation, the left side, set equal to y, and the right side of your equation set equal to y. Use intersect to determine the x-coordinate. The x-coordinate, that's going to be your solution. So why don't we go ahead and graph this in Desmos. I have y equals 4x to the fourth minus 3, and I also have y equals 2x plus 1. So here are our solutions. We've got two solutions, and they are not very pretty, but there they are. So that's how you can use intersect to find your solutions. You can also solve your equations algebraically. That's still my preference, but sometimes you aren't going to get very pretty solutions, so it's nice to have roots help you. So let's go back and solve a couple algebraically. So that just means by isolating your variable. So here I have 3 times 2x minus x equals 2x minus 1. I'm going to go ahead and distribute. That gives me 6 minus 3x equals 2x minus 1. Combine like terms. That gives me 5x minus 1 equals 6. Add 1 to both sides. 7 equals 5x, so I get 7/5 equals x. This was a degree 1 equation, so it has at most one solution. Let's try this again. If I have 2 over y plus 4 over y equals 3, I'm going to go ahead and add these fractions. That's going to give me 6y equals 3. I'm going to go ahead and multiply both sides by y to move y to the other side. So I get 6 equals 3y. I get y equals 2. Now I need to check and make sure that solution's in my domain. What number is not in my domain? 0. So 0 couldn't be a solution to this equation. Last but not least, number 3. If I have 2x over x plus 3 plus equals negative 6x plus 3 minus over x plus 3 minus 2. I'm going to add 6x plus 3 to both sides. That gives me 2x plus 6 over x plus 3, which equals negative 2. Now I solved this in class by pulling this out, but I could go ahead and multiply both sides by x plus 3, so why don't I go ahead and do that? Because what that does is that eliminates my denominator. So I have 2x plus 6 equals negative 2x minus 6. I'm going to go ahead and add 6 to both sides. I'm going to subtract 2x from both sides. That's going to give me 12 equals negative 4x, so I get x equals negative 3. Can that be a solution? No, if I plug in x equals negative 3, I'd have to divide by 0. So this is a contradiction. There's no solutions, right? My only solution would cause me to divide by 0.